Question 2. In this video, we're going to have a look at how we can graph linear relationships simply by looking at the relationships or looking at the equation when the equation is in something called slope intercept form. So what is slope intercept form? Well, it's when the equation is in the form of y equals mx plus c, m representing the gradient or the slope, and c representing the y-intercept. Now, two examples for this, we have y equals 1 over 2x plus 1 and y equals negative x minus 2. I'm going to show you how to graph both of these. Now, jumping into it, when we look at y equals half x plus 1, what we're looking at is we are in slope intercept form. So what it means is that this half here represents the slope or the gradient, and this 1 represents the y-intercept, or in other words, it represents c. Now, looking at c, when we're talking about the y-intercept, it is the location at which the line itself cuts the y-axis. So this point here. So simply looking at that, when we see a value of c or y-intercept as 1, we can simply go over to our Cartesian plane and mark it as 0, 1. So that tells us the very first point of a linear relationship on a Cartesian plane. Now the next part is we need to find the next coordinate, and we can do that using the m equals half. So recalling gradient is rise over run. It's the same as saying, well, the rise is how far do we go up, and the run is how far do we go across. So going at this point of the y-intercept of 0, 1, notice that we've got a rise of 1 and a run of 2. So what that means is we're going to go up 1 and then across 2. And this point here, that's going to give us our next point. So going from there, we can go, well, 0 plus 1 is 1, and 1 plus 2 is 3. So the next point's at 1, 3. Alright, now that we've got 2 points, what we can do is we can go ahead and draw a line that cuts through both of these points. And as always, we always have to use a ruler when we're well, not sketching, but when we're graphing, because graphing infers that we're doing something really neat and accurate. Alright, awesome. So that is now graphed. Now, the final touch I'm going to put on it is I'm going to write the rule, and in this case the rule is y equals a half x plus c, and we're done. Now, example 2, we have y equals minus x over 2. So simply looking at this. Alright, so the information we can infer from this particular relationship is the run, or the gradient itself, is equal to minus 1, and the y-intercept is equal to minus 2. So simply starting with the y-intercept, we look for minus 2 on the Cartesian plane, and it's here. So y equals minus 2, it's 0, minus 2. And then we have to use the gradient here of minus 1. Now notice minus 1, it's not a fraction, but rather it's an integer. What we can do is we can transform this into a fraction by simply going minus 1 over 1. And therefore we have a rise and we have a run. So, getting this point here, we have to go either down 1, across 1, or we can go up 1, back 1. In this case, we'll do both. So we'll go down 1, across 1, and it leads us to this point here. So therefore the point is going to be, that will be 1 minus 3. Or we can go the other way. Doesn't matter. This would be negative 1. So, yep, negative 1, negative 1. So therefore, in this case, we've got 3 points, but we only need 2. So you don't have to mark both of these orange points. You simply pick one. Now, next step is I'm going to grab my ruler and draw a beautiful line that cuts through all of these points. And boom, that is beautiful. And finally, I'm going to label it. So in this case, it is y equals minus x minus 2. So this has been a video on how we can graph linear relationships simply by observing them in slope intercept form.